Hello and welcome back to our series going through the GCSE Physics spec. The next thing we're going to be looking at is calculating acceleration. For this, we're going to be looking at an equation. We're going to be looking at how to apply that equation to questions. Before we start, we need to talk about what is acceleration. So when we use this word, what do we mean? Now in physics terms, acceleration is the rate of change in velocity per unit of time. Okay, it's a very, very fancy way of saying we're changing our velocity and we're doing that over a stretch of time. Okay, that's all that really means. Now, really important, we use the word velocity because remember, velocity is a speed plus a direction. So when we talk about accelerating, the direction that you're increasing your velocity is really important. So that's why we use the word velocity, because acceleration and velocity are both vectors. Then we've got this change, and you're going to be introduced to potentially a new symbol, which is this triangle symbol. This triangle means change in. It's change in something. Okay, and in a unit of time, we know that to be seconds. Now, that's the way we write all of this. However, there is a really simple kind of equation that we can write instead, which is A equals V minus U over T. Okay, or that delta V over T. And really, you could also say delta T because it's a change in time as well. But we don't normally do that. We normally just do the delta for the velocity. Now, if we head over to our formula triangle just on the left-hand side, we can add this into our formula triangle and then we'll talk about what each of those symbols mean just below this. So in this formula triangle, we're going to look at A in the top, V minus U, and in this bottom corner, T. Okay? Remembering on our formula triangle, this line here is our times, and then these two lines up here are our divide. So we cover up whichever one we want. Now let's just head below and talk about what each of these symbols mean. So A is a bit an obvious one. This is acceleration. Now you'll notice a lowercase a, that's really important. Okay, the lowercase, all of these are lowercase. Acceleration is measured in meters per second squared. Okay, and we'll talk about why that's squared in a second when we look back at our equation. Now this V here, yes, it stands for velocity, but in this case, it's a specific velocity. So at the top here, we're trying to find a change in velocity. So we've got V minus U. So you want to find a change in something, you need to know where did it end and where did it start, or where did it start, where did it end, and then what's the difference. Now in this case, it's really important we have these the right way around because acceleration can be a negative number. That's called deceleration. It can be a negative number. So these need to be a specific way around. So for our V is going to be our final velocity. And like velocity meters per second is our unit, okay? And then, or you could call this end velocity, I guess. End velocity, final velocity, same thing. And then for U, this is our start velocity. Once again, measured in meters per second. Now in the exam, they won't necessarily say start, they'll probably say initial velocity. Okay, once again, still meters per second. Either of those two words for those two, final or end, is fine. Start or initial is fine. Just make sure that your symbols are the right ones. Okay, and then finally we have T, which is time. In this case, measured in seconds. Now you could have this all in minutes. You could have this all in hours. It's just not as common. We normally have it all in seconds. Seconds is our kind of standard unit. Okay. Now, talk about these units here. If we just go back to our equation up the top, and we can kind of see, I'll just change the color here. If we've got meters per second minus meters per second, still just going to have meters per second up here. Okay. And sorry, in this case, we're trying to find our acceleration unit. So we're going to still have meters per second here. Now we've got divide by, and here we've just got seconds. So we've got meters per second divided by seconds. So that ends up as kind of like meters per second, okay, divided by seconds. So if you're good with your math skills, you'll know that that ends up being basically meters per second times 1/second. So you end up with meters over second squared, which is why our acceleration ends up with meters per second squared. Okay. So that's just something you need to remember. If you're struggling to remember that, just practice, 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 and try and always link whenever you hear acceleration, meters per second squared. Okay. Now, just a couple of key terms. These are kind of things that come up in exam questions that sometimes catch people out. The word rest or stationary. This just means the velocity is 0 meters per second. Sometimes they say a car goes from rest, or they say a cyclist slows down until stationary. That just means that velocity at that point would be 0. Constant means no change. So if someone's traveling at a constant acceleration, it means their acceleration is not going to change throughout that whole thing. Okay. As we go through the questions, if we think of any more, I'll throw them in there. Okay. Or you can fill some in if you see other words in questions where you're like, oh, I didn't know that's what that meant. You just fill in that space right there. Okay. Now, let's have a look at question number 1. We'll do this one together. And then, like always, you can download this worksheet from the link in the description, or if you're one of my students on Google Classroom, it is uploaded on Google Classroom with the video, and then you can finish the other 2, and in the next video we'll go through those answers. So a car starts from rest, so here we go, we've got that from rest that we just spoke about. Okay, so that's 0 meters per second, it's like I planned it, and accelerates at a constant rate. Oh, there's another key word. Okay, so no change. After 8 seconds, it reaches a velocity of 24 meters per second. Calculate the acceleration of the car. Now, whenever you are doing an equation question in physics, there is a checklist you should always follow. Okay? So, number 1 is equation. Okay? So that means just write the equation. It doesn't matter if you've written it before, always write it again. Okay? So, A equals V minus U over T. Okay. Number 2, let's do some different colors just to brighten this up. Number 2 is variables. So in this one, we write down all of the variables, so all of the parts of the equation, and we write down what numbers we have, also what we don't have. So we don't know A. So V, here's where we need to find out. So V, remember, is our final velocity. So our final is until it reaches a velocity of 24 meters per second. So that's 24 meters per second. U is our initial or our start. So a car starts from rest, so from 0 meters per second, and T was our time. We've got here 8 seconds. Number 3, let's do that in green, is substitute. Just squeeze that in. And this means put our numbers, our variables, into the equation. So A equals 24 minus 0 divided by 8. Okay? And then number 4 And I guess number 5, these kind of come together, is answer and units. So answering units. Now units you could kind of put in any place on this checklist, but I always just put it at the end. But number 4 is to write your answer really clearly so the examiner can see what your answer is. And then units is to just check and make sure that your units are what you expect it to be and also what you're asked for. Sometimes they want it in a very specific unit. So from doing this equation here, we know that A equals 3. So that's our answer. And our units, as you said earlier, meters per second squared. And I can see here we've got seconds, meters per second, all matches up. It's exactly how you should lay out every single question. Now, you don't need to write the checklist at the side, just the bit in the middle. Now, an examiner is looking for those things. The only one that you don't get the mark for is the variable. But equation, substitution, answering units are all worth marks in that exam. So it's vital that you add all of those in and show them really clearly on your exam paper. Now you have a go at B and at C. Okay, and once again, if you see any special words here, add them into your key terms and we'll kind of see what you guys come up with. Comment below any key terms that you think are super important when calculating acceleration. And I'll see you next time where we're going to look at velocity time graphs.